that called? That's the atrium. The one on the sides, the floppy one under it, is the first chamber that it enters, and that's the atrium, right? There's only one, even though it looks like there's two. Then it goes into this one. What's that? Ventricle. Good. There's one ventricle. So the shark heart has two chambers, and all of the blood going through those chambers is deoxygenated. So then it gets pushed through what in our heart would probably be the aorta, but here they call it the conus arteriosus, this big, thick vessel right there, very thick. Now, in some hearts, you're going to see little red lines on the surface of the heart. You can't really see that here. But if you do see those little red lines, what are they? Coronary arteries. Excellent. Okay, now the coronary arteries are filled with oxygenated blood. Otherwise, the heart wouldn't be able to beat, because remember, the heart is a muscle. In order to contract, muscles need to be using their mitochondria to break down that glucose to keep going, because the heart never rests. So the heart needs a lot of oxygen. So that's the only oxygenated blood you'll find. Inside the chambers, though, it's all deoxygenated. Okay, so you go up through the conus arteriosus, then we flip the mouth open. And although you can't see them, inside the tongue there would be afferent bronchial arteries. Okay, afferent bronchial arteries would spiral out like this and take the blood to the gills. The blood gets oxygen from the gills by countercurrent exchange. Remember that? Okay, countercurrent exchange system through those lamellae, those respiratory surfaces there. And you can see how well vascularized they are. Lots of red blood there. Gets oxygen there, then comes back down, and you guys still need to get the skin off this so you can see it. You were doing the right thing. You just got to get the rest of it off, okay? But what you can't see here is like these branching, oh, there's one. See that pink line right there? That's an efferent bronchial artery. So afferent goes to the gills, efferent comes back from them. Not nice and rich with oxygen, so you can see they're nice and pink. And they come down this way and then go to the dorsal aorta. If I lift up all of this stuff, and I could trace the dorsal aorta starting right about there and going all the way down the bottom body of the shark. So if we lift up the viscera, you can, yes, there we go. See the dorsal aorta? Bright pink going all the way down the shark, supplying oxygenated blood. Okay? All right. So, yeah, it's not a good chart to show. So I'm just going to follow the dorsal aorta. Now, the dorsal aorta is going under all of this, right? Trust me on that. And the first thing that it really branches into is this really big artery that's right under the stomach, and it's loose, and it's all by itself, so it's pretty easy to find. It's this one here. What is it? Celiac. Very good. The celiac artery is one of the first branchings of the dorsal aorta as it travels towards the posterior end of the shark. Okay. The celiac is carrying oxygenated blood to the digestive organs. It branches into several arteries. The ones I want you to know are the one going to the stomach, which is the gastric artery. Anything pink on the stomach? Gastric artery, right? And also one going through this mesentery here to the pancreas. So it's called the pancreatico-mesenteric, because that exactly describes where it's going and what it's going through. And it looks like in this case it's right here. That pink line there, so it branches. Pancreatico, that's mesentery there. It's not my glove. So, pancreatico-mesentery going to the pancreas, which is there, okay? And then as you go down, there are some other arteries down here that are important to know. Oh, sorry about that. Sorry. Any pink line on the intestine is going to be the intestinal artery. Any yellow line is going to be the intestinal vein. Okay? Not mysterious. Down here, though, these are a little harder to remember sometimes. You see, you had all these arteries, you just had to look for them. All right, so there again, there's the dorsal aorta, and it's branched into the celiac up there. Now it's flowing still, and it's going to branch again a couple times. The first branching down here is called the anterior, because it's the most anterior branching in this region. Think of it that way. Anterior mesenteric goes up here to the intestine. Lienogastric branches off second and goes underneath the anterior mesenteric to the spleen. The last one is down here, and it's supplying the rectal gland all by itself. This is the posterior mesenteric. So, anterior mesenteric, lienogastric, posterior mesenteric.
Which one's a kidney compared to the seven?
Okay, The seminal vesicle is going to be down here at the posterior end. And this is a male, yes. So that's your seminal vesicle. It's a long silvery pouch. And then as you go up, what you look for is you look for the vas deferens. This when it starts doing this, that's the vas deferens. And the kidney is the dark shadow next to the vas deferens. There. You see that, Louis? Yeah. So the sperm travel through that, okay? And the urine is collected from the blood in this. Okay? And the seminal vesicle secretes seminal fluids in with the sperm. And then I think you got some sperm sac down here, sort of. There's a sperm sac there. And urogenital papilla is right, that little point sticking up right there. And both the urine and the sperm come out of the same hole. That's why they call it urogenital. On the female, they call that same one just the urinal, right? The urinary papilla. Okay. Anybody need anything else while I'm here? How about we do a little test? What's this? Function? Buoyancy? More. Emulsifying fat because it makes? Bile. Good. Where's the gallbladder then? This floppy thing. Yeah, that's a nice long one there. That's the gallbladder. That's a very clear gallbladder. Okay. How does the bile get to the intestine? Bile duct, which is almost always tied up with the hepatic portal vein and other things. So if I pin something that looks brownish or grayish in this, that's the bile duct. If I pin the yellow one, what is it?
A vein.
It is a vein. It's the hepatic portal vein. I didn't mention that one. So hepatic portal vein takes fluids, it takes blood from the intestine and to the liver to be cleansed. So lots of the nitrogenous wastes that are still in the blood from food that are absorbed in the intestine go to the liver to be detoxified, changed into urea. Remember that? We learned about that. And then that urea then goes to the kidneys to be filtered out. Do you remember the couple of ways that a shark uses to make its blood more isotonic with the seawater?
Rectal gland.
The rectal gland is one way, and also the kidneys. What do? They remove urea from the blood, but they leave a little bit more behind than we do. So the shark maintains a slightly higher urea content in its blood than humans do, or even other fish do, as another way of balancing their osmotic pressure against the seawater. Okay. What's this? What special name does it have, though?
Duodene?
I mean, because why? What's inside it?
Spiral.
It's got the valve inside it, which looks like a spiral staircase. Thank you for remembering. Yes. So the valvular intestine is what they call it, and its purpose?
Absorption.
Absorption of nutrients. Yes, that's why that valve is there. It increases the surface area for absorption. Okay, surface area is a big concept in bio. You remember that. What about this? What's this?
Pancreas.
Pancreas, very good. And is it the only part of it?
No.
No, there's another part of it down in here. This would be the ventral part, because it's, I know, yeah, we're on the backs, right? So this is the ventral part, and this is the dorsal part. And what's the purpose of the pancreas? It secretes insulin. It secretes a lot of things. It secretes hormones and enzymes that help with digestion. That's why it's right there on top of the intestine. What about this one? Spleen. That's the spleen. Very triangular, the spleen. Okay? What does it do?
Like store blood.
Well, the blood goes through it. It recycles dead red blood cells. Dead erythrocytes, if you want to be fancy about it. Okay? What's this? Stomach. Okay, purpose? Digestion. Chemical and physical. So there's both of those going on. What about the folds inside it? Rugae. And what are they called for?
Absorption?
They increase surface area, that's true, but there's no absorption here.
Don't they mix it?
They help, yeah, mainly it's for stretching, yes. It's wrinkles so that when he swallows something big, the stomach can stretch out. It also increases surface area for excretion of acids and enzymes to help. But there's no absorption here. The absorption happens down here. Okay, the main purpose of the stomach, is to take a full, squid that it swallowed and change it, mush it into chyme. Okay, let's see. We've gone over a lot here. Oh, the brain. How are you doing with that?
Our brain sucks.
Okay.